Hi, my name is Scott Ritter. I'm a professor in the Department of Geological Sciences at Brigham Young University. I came to BYU, I think as a lot of students do, not really quite sure what I wanted to major in. And so when I got here, I took a Geology 111 class, and it rekindled that excitement that I'd felt, and I have never looked back. President Worthen has really put an emphasis on active learning and experiential learning. We've taken that to heart here in the department, and so we get to take students to places like the Bahamas, Hawaii. We've been to the Alps, been to the Himalayas, and my personal research has taken me around the world as well, to Kazakhstan, to Russia, to many places in Europe. And we have one of the most fantastic natural outdoor laboratories here in Utah, whether it's along the Wasatch Front with all the spectacular scenery, or pop over the hill to the Colorado Plateau and Moab, where the national parks are, and all those fantastic exposures of rocks. It's just the greatest place in the world to do geology. And because these rocks and fossils are everywhere, we have the opportunity to go and explore these different regions. Geology covers a wide range of disciplines. The discipline that I have focused on is sedimentary geology and paleontology. I work with limestones, I work with sandstones, and I also work with microfossils. And the group that I work with are called conodonts. You can see a couple of them over my shoulder here. These are the teeth of an extinct group of eel-like vertebrates that change very rapidly through time, so we can use them to precisely determine the age of specific rock layers, which allows us then to correlate them not just through Utah and through the western United States, but actually around the world. And it's really been a cool experience. We've been able to answer a lot of really interesting questions. When you're collecting conodonts, it's a little bit, you go on faith, because it's not like trilobites or dinosaurs where you can actually see them when you're out in the field. You look for the right type of rocks that were deposited in ancient oceans, and you bring them back, and then you crush them up, put them in an acid. And since these are ancient teeth, they don't dissolve like the limestone matrix that are made of the same stuff that human teeth are made of. And so they form part of the acid residue. You just go in and pick them out and then identify them. Climate change is an important topic now. And so to better predict what's going to happen in the future, it helps us if we can look at past climates. And these timelines given to us by conodonts and by refinement of the timescale allow us to really get a sense of the timing of climate change in the past and the amplitude of climate change in the past. So that's one thing we're really excited about. The challenges are going to continue. We need fresh water, we need greener energy. Again, as the population explodes, we'll have issues with tsunamis, we'll have natural disasters. You can think of volcanic eruptions that are happening in the Canary Islands and in Tonga. And geologists need to be there to help understand how to interact with the Earth in an equitable and also safe way.